Culture media, preparation, sterilization, and storage. Like everything living, microorganisms too need nutrients, a source of energy, and certain environmental conditions for their growth and reproduction. The microbes have adapted to their natural environment to survive and thrive. In a laboratory, these growth requirements must be met artificially by means of culture media. A culture medium is basically an aqueous solution to which all the necessary nutrients required for the growth of microorganisms have been added. Culture media can be broadly divided into two major groups: liquid media, such as peptone water and nutrient broth, and solid media, such as blood agar, which is prepared by adding 1 to 2% agar to the liquid media. Besides these two, semi-solid media are also used, which are prepared by adding 0.2 to 0.5% agar to the liquid medium. Though liquid media can be fortified with different nutrients and permit growth of most bacteria, there are certain disadvantages as compared to the solid media. First, growths of bacteria do not exhibit special characteristic appearances and hence are difficult to identify. And second, isolated colonies cannot be separated from a liquid medium. Both these deficiencies can be overcome by a solid medium. On solid media, different microorganisms give distinct appearances in the form of colonies, which are very useful in identification. Also, solid media are indispensable for the isolation of pure cultures. That is, an organism can be easily separated and grown as a pure line, thus helping in identification. Culture media can also be classified as basic, enriched, selective, indicator, and transport. Basic or basal media. These are simple media which support the growth of microorganisms that do not have special nutritional needs. Examples are nutrient broth and nutrient agar. These are mainly used for the preparation of enriched media, for maintaining stock cultures of control strains of bacteria, and for subculturing of bacteria from selective media for performing biochemical and serological tests. Selective media. These media have certain inhibitory substances added to them which inhibit the growth of unwanted bacteria and only promote the growth of pathogenic or disease-causing bacteria. These media are used for sites which have a normal microbial flora to prevent the growth of unwanted bacteria overcrowding the pathogenic bacteria. An example is DCA medium for dysentery bacilli. Indicator or differential media. These media have certain substances or indicators added to them which help to differentiate between bacteria, usually by a color change. An example is McConkey's medium, which produces red-colored colonies of bacteria which are able to ferment the carbohydrate present in the medium. In contrast, bacteria which do not ferment carbohydrate produce colorless colonies. Transport media. As the name indicates, these media are used to transport specimens from the patient's bedside or health centers to a microbiology laboratory. These are usually semi-solid media which promotes the growth of certain delicate organisms which might usually not survive the time taken for transportation of the specimen to the laboratory. These also prevent the pathogenic bacteria to be overgrown by commensal bacteria. An example is Kerry Blair's medium, which is used for the transportation and preservation of enteric bacteria. Preparation, sterilization, and testing of culture media. Aseptic techniques. All microbiological media should be prepared in a sterile environment employing aseptic techniques. Disinfect the work area. Wash hands. Wear gloves, lab coat, and tie your hair. Reconstitution of dehydrated media. Always use freshly prepared distilled or deionized water. Open the culture medium container away from current of air or moisture. Wear a mask and gloves. Weigh the powder quickly, accurately, and without creating clouds of dust. Close the container as soon as possible. Pour half the required volume of distilled water in the vessel, then add the weight quantity of medium, mixing briskly for a few minutes. Pour the rest of the distilled water down the sides of the vessel to wash away any medium sticking to the sides of the vessel back into the solution. This is important as dry culture media powder, which does not dissolve, may not be sterilized in the autoclave and can be a source of contamination. Media containing agar should be heated first to completely dissolve the agar before autoclaving. Bring the medium to a boil without burning. Sterilization of culture media. Usually, culture media in volumes up to 1 liter are sterilized by autoclaving at 121 degrees centigrade for 20 minutes. Most culture media will require final sterilization in an autoclave at 121 degrees centigrade for 20 minutes, but it is important to follow the manufacturer's instructions as it may vary for different media. Overheating of the media should be avoided as it may cause the formation of toxic products due to chemooxidation. Distribution of media. Media may be distributed in plates, test tubes, or bottles. Standard aseptic precautions should always be followed. It is preferred to work within an inoculation hood or cabinet filled with a filtered air supply. Always heat the mouth of the container from which the medium is being poured in a flame. For making a slant or a slope, the tubes have to be laid at an angle which allows the slant to be formed. The medium is poured such that there is a thick butt at the bottom. This shape provides a large surface area for inoculation. If the medium is used for a stab culture, the test tube should be half filled with the medium and allowed to set in an upright position. For distribution into plates, the melted sterile medium is poured on a flat surface. Pour such a volume that the medium is about 4 mm in height from the base of the plate. The plates are left undisturbed till the medium is set. If you find bubbles on the surface of the medium, remove them easily by running a Bunsen burner flame across the surface of the medium. All poured plates should have even depth and formed firm gel. The surface of the agar plates should be smooth and free from bubbles. Storage of prepared media. The recommended shelf life of prepared culture media varies considerably. Screw cap bottles of nutrient broth and agar can be stored for 6 months at low ambient temperatures. It is important to store all media away from light. Agar plates should be stored at 2 to 8 degrees centigrade in sealed containers to avoid loss of moisture. Do not freeze the media. Fresh media are better than stored media. After pouring the media into plates, leave them undisturbed till agar is solidified. Then, stack the plates and seal them in plastic bags and store at 4 degrees centigrade.